Hello, and today we are going to talk about direct variation. So let's start taking some notes. So a function in the form of y equals k times x is a direct variation where k is the coefficient of x. The variables x and y vary directly with each other, and the graph of every direct variation goes through the origin 0, 0. So write this all down, but in general, a direct variation means that how does the variable x vary with the variable y? All of them are always going to go through the origin 0, 0. And the letter k up here is called the constant of variation for a direct variation. It's basically saying, what do I do to x to get y? What number am I going to multiply x by to get y? That's your constant right there. K is your constant. And it sounds complicated at the moment, but once we start applying this, you'll see it's not as tricky as it seems. So, in an equation, if there is no lone integer, the equation will be a direct variation. So are these direct variations? I have 5x plus 2y equals 0, and I have 3x plus 4y equals 6. Now remember, the equation for a direct variation is y equals k times x. Now notice there's nothing being added or subtracted to the end of the direct variation equation. So with that said, let's go through these two problems and solve for y, because our direct variation equation is y equals, so they're simplified to the form of y. So I have 5x plus 2y equals 0. I need to get 5x to the other side of my equation. Those cancel out, and I'm left with 2y equals 0 minus 5x, or negative 5x. And then I'm going to divide both sides by 2. And I get that y is equal to negative 5 halves x. And that is my direct variation equation. Meaning that for every x, y is going to be negative 5 halves the size of it. Notice there's nothing added or subtracted to the end. This is a direct variation equation, so yes. Let's look at this one. So I'm going to subtract 3x from both sides. And I'm left with 4y equals negative 3x plus 6. Then I divide both sides by 4. And I get y equals negative 3/4 x plus 1.5. This is not a direct variation because I'm adding 1.5 at the end of it. Because you're adding 1.5, it's not varying directly. It's basically saying y is equal to negative 3/4 x, but with an additional 1.5 added to it. You can't add that additional 1.5 to find out how they vary directly. Writing an equation given a point. So write an equation of the direct variation that includes the point 2, 3. So remember in our point, this is my x variable, this is my y variable. And the equation for a direct variation is y equals k times x. Well, I'm going to take the 2 and plug it in for my x. I'm going to take the 3 and plug it in for my y, and I'm going to solve for k. So I get 3 equals k times 2. And I want to find out what my constant is, my constant of variation, the letter k. So I'm going to divide both sides by 2. Then I get that k equals 1.5, or 3 halves. But up here it says write an equation of the direct variation. So now I need to take this and I need to plug it back in to my equation. Y equals k x. So my final equation is y equals 1.5x. Or, for the sake of working with slopes eventually, another way to write it is y equals 3/2 x. Try this one on your own. We get y equals kx. So this is my y, -4. 3 is my x. So it's -4 equals k times 3. I'm going to divide both sides by 3, and I get k equals -4/3. So therefore, I plug it back in for my k, and I get y equals -4/3 x. Suppose y varies directly with x and y equals 10 when x equals -2. What direct variation equation relates x and y, and what is the value of y when x equals -15? Take a moment and try and solve this one on your own. So because I know it varies directly with that, y varies directly with x, I'm going to use the equation y equals k times x. And since I don't have my constant, my letter k, I need to use y equals 10 and x equals -2 to figure it out. So I'm going to plug those values in. I get 10 equals k times -2. And then I'm going to divide both sides by -2. And I get k equals -5. So my direct variation equation that relates x and y is y equals -5x. And the next part says, what is the value of y when x equals -15? So I'm going to plug that in. I get for x, I get y equals -5, and when x equals -15, what is the value? Well, -15 times -5, that's a negative times a negative, so it's positive 75. So your equation is y equals -5x, and the answer when x equals -15, y equals positive 75. The weight of an object varies directly with the mass of the object. If the bowling ball has a mass of 6 kilograms, the scale reads 59. Write an equation of the relationship between the weight and the mass. So because the bowling ball has a mass of 6 kilograms, the scale reads 59. We need to figure out what the mass is. What the weight is. So basically, I have to figure out what do I multiply the mass by to get the weight. So I'm going to use the direct variation equation. Y equals k times x. And since the weight of an object varies directly with the mass of the object, that means that the weight depends on the mass. That's a little tricky. Once again, the weight of the object varies directly with the mass of the object, meaning that the weight depends, varies directly, it depends on the mass. So since it depends on the mass, that means that the weight is going to be my y. So if a bowling ball has a mass of 6 kilograms, the scale reads 59. So write an equation of the relationship between the weight and the mass, divide both sides by 6, and we get k equals 59 over 6. So my equation is y equals 59 6 x. And then the final part, looking at tables. So write this down because this is important. It says you can rewrite the direct variation y equals kx as y over x equals k. When two sets of data vary directly, the ratio y over x is the constant of variation, or our k. So for each table, here are the tables down here, It says use the ratio y over x to tell whether, there should be an h in there, W-H-E-T-H-E-R. Miss Grand doesn't get mad at me, hopefully. So for each table, use the ratio y over x to tell whether y varies directly with x. If it does, write the equation for the direct variation. So let's look at this one. I need to figure out the ratio of all of these x and y coordinates. So I'm going to start with the first one. Since it's y over x, I'm going to look at 3.2 over negative 2. And that comes out to about negative 1.6. Good. Now let's look at the next one. The y over x here is 2.4 divided by 1, or just 2.4. Well, this first point had a direct variation. Its ratio was negative 1.6. This point right here is 2.4. Notice these two values are not the same, negative 1.6 and 2.4. Since these two are not the same, the answer is no. It is not a direct variation. The ratio y over x is not the same for all these data pairs, so y does not vary directly with it. Try on your own this other table. So remember, you have to go through the entire table to make sure it works for all the points. So let's check it out. 6 over 4, because my ratio is y to x. I'm going to put a bubble around this. There we go. So 6 over 4, well, that comes out to about 1.5. 12 over 8. If I simplified that, that comes out to about 1.5. And then 15 over 10, that comes out to about 1.5. So the ratio y over x equals 1.5 for each data pair. So that means that y varies directly with x. Awesome. So what's our equation? Well, because the ratio comes out to 1.5 every single time, the equation is going to be y equals 1.5. And we know that it's 1.5 because if we go back to the top, remember, your k is equal to y divided by x. Down here, y divided by x is 1.5, so k equals 1.5. That's the lesson. I hope you understood it, and I hope you took some good notes. Don't forget to take the Kia quiz, and I hope you have a wonderful day. See you later.